next part we've got to assemble the surface mount printed circuit boards for the capacitors. And as you can see there, we've got two of those. One's for the times 1, one's for the times 10. And you can see how they tie in together with the through-hole circuit boards that we put together. So there's 4 of those, and there's 2 for the surface mount. I found the easiest way to separate the boards is to just lean on your desk and just press down gently, and they just break apart like that. So we just put the first 4 of the surface mount capacitors on. As you can see, I'm using a reasonably fine tip here and just going through and carefully putting solder on. When we're looking at the surface mount, you can see that all the 1 microfarad in parallel here, again in parallel, and then you've got a single. Capacitors in parallel is the same as resistance in series. So what you'll have is 1 microfarad times 8, 1 microfarad 4, and times 2, and then you get the single. So across here we should read 8 microfarad, and if you're looking at the 10 section, that should be 80 microfarad, 40, 20, and then obviously 10. So we're just going to measure those on the LCR meter and see what we come up with. So we're measuring from the B terminal, and this is your times 8. So if you put it on there, you can see that we've got 7.5 microfarad. This should be 4. We've got 3.78. As you can see, we've got 1.9, and there's your single there, which is 1 microfarad. We'll check the 10 board again, attaching to B, and again you've got your 8, which should be 80. We're getting 70. This is your 4s, so it should be 40. We're getting 35. That's supposed to be 20. We're getting 18, and then you've got your single, which is 9.4. So you are getting some variation in the surface mounts. We've got our printed circuit boards, and we've got our connecting pins which have got to be soldered on. Now they solder onto the right component side like that. We'll need to solder those on, and then we can plug them into the switch. So this is the ones going on. And they plug in and sit like that. And then you've got your 10s, so the ones go first, and the 10s are on the outer. And that plugs into there. So what we're going to do is make some interconnections going from point to point here, and we're going to do it there as well and over here. So what we've done here is just moved it down to the ruler until we're on about 12mm. Just hold it there, and then we just snip that off. Once we've got it snipped off, we just found a point on our pliers which equated to the distance between the 2 points on the board, and just put the wire in so it's about central. Doesn't have to be perfectly central, but close enough. And then we just bend it over. As you can see, we've got one in here which is connecting this first board here to the next one, and then we'll do the same and then the same again. Then we're going to connect this point to here and then this point to here. So as you can see, we've got our bridging wires in for the board. Now we need to attach one to here and then tie these 2 boards in on both sides. So that's the next set, and you can see under here we've trimmed them all off. The remaining tin wire that's they're supplied, we've just tied into the end of this board and the end of that board there. And what we'll do is just cut that off a bit longer, and then we should be able to feed that through and put the 2 boards in. So a slight bend in here so it matches up with the hole it's got to go through, and that's with your board push right down into the socket here. We've done that to both sides just so it looks nice. And the other thing that's important is that these come apart, so to actually put that on, you can get your your heights and bends correct. Then you just push it back onto the board and it's ready for soldering. So you can see here how I've just unclipped that particular board, and I've just lined that up so it runs onto the wires. Now we can just move it down, it just presses in, and now we should be able to get that nice and straight and just solder that in. The last two for that part of the project, and that's all done. So that's how it looks from the back, and if you pick the whole thing up, you can see that the numbers are the right way up, and you're starting from your picofarad through to your microfarad. So what we're doing now is putting on these connecting wires here, which basically bridge from one board to the other board. You can see that here on the actual diagram that they got drawn here. That's the wires there. So I've trimmed one end slightly smaller than the other end, and the reason behind that is that all this area here, what you're soldering to is on this side, so you basically have to push the wire in slightly to get a gap to get the solder on to the board. And I've attached these to the bottom row of holes. If you turn that around, you can see that there's a lower row and a top row right across. So I've attached the wires to the bottom row. On this side, which is the smaller end, I just did a right angle turn, and I connected all the wires into position first, and then I soldered these ones, the right angle turn, just making sure that they were kind of flush with the board. And then after I got that done, then you can come back and position these so you've got a small gap, so you can get your soldering iron there to solder it onto the board. Here we're going in on the bottom holes along there, and then you end up with a spare at the end. And then if you look over the side, you can see how the top lead of the resistor folds over and goes to the one to the left here, and so forth down the row, and it's done the same along here as well. Now it's a bit of a tricky exercise, actually doing the lining up, one to get these to sit reasonably flat against the boards, but also to fold this top lead over and to get it sit flat onto the soldering pads. Now the other thing that you've got to be careful of too, and I'm using a fairly small soldering iron tip, is make sure you get no bridging right between the pads. It's very easy to do, and you're really going to have a steady hand and take care. We made sure all the switches were on 0, or otherwise it's going to select points of reference. So we did that, and then we came through and got the multimeter, and that's your common there, and then we put our meter common on there, and then to the last solder point on the board. Now if you have done it right, like on this case here, you should get 9 ohms, and then you should get 90 ohms and 900, 9k, 90k, and then almost 1 meg. So that's how it sits in the right front panel, and as you can see, you can select your single ohms up to 100k ohm selections. So what we have here is the terminal board, and we've got the switch put onto that board. Now we did find difficulty getting the switch on. The main areas are these corner pieces, which are just basically frame supports for the switch itself. Now they are a very close fit, and you've got to be careful putting those in, right? And also with reference to the switch pins, you can see here there's a group of 6, then 8, then 2, so it can only go on one way. We've got our switch positions on and put in our terminal outputs, and you can see on the back there how all that goes together with these tags for the terminations. I'll probably just lift those up a bit and then we'll just attach the wires to those. There's plenty of room in the box. So as you can see, we've got the wires attached to the various points as per the schematic. And the way we did that is by putting the switch into position, and then we're measuring from the switch to the point that they secure to. Now we found that the supplied wire, which is all these, were a bit large for the pads that they had to go through. So what you had to do is basically cut the insulation off and then take 2 or 3 strands off each wire, to get them to fit, and a little bit more when you attach them to these points, which is even smaller again. So you kind of had to cut it down and then take about 4 or 5 strands off to get it to fit through. So we're up to the last of the screws for the switch, and we'll just tighten it up just so it's firm, not over tightened. So that's all the front panel assembled, and as you can see here, we've got all the wiring connected up. So we finally got all the resistor banks repositioned, and as you can see here, all the legs are coming down this way now. So I went through and checked each resistor bank to make sure that it came up with the correct number, 9 ohms, then 90 ohms and 900, etc. And then after that we put these 2 wires back on, and we've just gone through and checked the bank. The orientation of the leads is to the capacitor board, which is opposite to the actual wiring diagram that's on this particular construction manual that was supplied with the kit. So just be aware of that. It's very important to take attention to the wiring diagrams, to the pictures that they supply, and if you see any differences, it's probably worthwhile questioning before you start the kit. Now I had noticed differences, but I just thought they just threw in some picture. I wasn't expecting the wiring diagram to be incorrect. The other thing I'd like to point out here is on the capacitor board, you can see that the wires are on this end, we've got them on that end. It doesn't matter, this is all common right down through both sides, as long as you've got what they call the positive lead here, there, and the negative lead here attached to that side, which is what they got up there. So as long as you do that, that's fine. Other than that, the kit is a very high quality kit, as in the parts and the boards and the general construction. I'd certainly recommend it. Alright, so as you can see here, I'm just doing a resistance measurement. We've got 110 on the dial there, which is 110 ohms. You can see that we're reading about 111, which is about right. We had about 1 ohm lead resistance and contact resistance. If I put another one in, you can see now we're up to 1.1k, which is about right. You are going to get slight variations in these, even though these are 1% resistors, because you've got the lead resistance and you've got all the internal wiring resistance, etc., and contacts. The other thing that we can do is test capacitance. So you can see there that we're on the capacitance, and this is the bottom group here is for your capacitance. You can see here that we've got a residual of about 0.037 nanofarad. So if I put in 100 nanofarad, you can see there we're getting about 101. Keeping in mind, I think the capacitors were plus or minus 10%, so you are going to get a little bit of variation. There we just put in 10 nanofarad. So versatile kit, good construction. just be careful, as I said before, that when you're putting these kits together, make sure you read through the documentation that's supplied. Like I said earlier, we did notice that there were differences, but we thought they were just photographic differences. But it turned out to be that the photographs they used were correct, and the actual wiring diagram that was supplied was incorrect.